All right, and now that it's 4 minutes after the hour, we can officially get started then. So I'm Kalen. Nice to meet everybody here. Good to see you. Happy holidays again. Yeah, thanks for joining us. End of the year. I know things get busy, or at least family time becomes more important. So thanks for stopping by. We have some exciting presentations today. So I work in the community as a contributor on the project. So you'll see me in Slack. If you have any issues, feel free to reach out. I focus on Argo Workflows primarily in my work at PipeKit, which is a startup that provides a multi-cluster control plane for Argo Workflows. And today we have an agenda of just community presentations. So joining us today is Adam from Equinor and David from Intuit. Thank you all for coming to share these exciting projects you have with us. So we'll kick it off with you first, Adam, Flowify, and I'll let you give the full intro, but it's a nice GUI that for Argo Workflows that you all developed at Equinor. So really excited to see the latest update from you all. And then we'll continue with a presentation about from Adam or from David related to Argo events and event streaming. So yeah, thanks. I think you have the screen, Adam, right? Is it working on your end?
Yep. Just shout if you don't see my screen. So
yeah, take it away.
Yep. Thanks for inviting us to this community meeting. I'm Adam. So a little bit of a plan for the next 10-15 minutes. We're going to show at least who we are and why we build Flowify. Give you a bit of a demo and a plan of what we plan to do with it within Equinor. So for those who don't know us, we are not an IT company. We are an energy company based in Norway with renewable energy, carbon capture, and oil and gas. So if you want to learn a little bit more about us, it's loop.equinor.com. So part of our strategy is open source. We embrace open source, and by default, most of our software code developed should be open source. That's why Flowify is open source, and we are share it with the community here. So Flowify start with a project that from several of the super users of Argo Workflow within Equinor, and we enjoy the simple of the YAML file. We enjoy its Docker based Kubernetes technologies, but we want to push it a bit further. Can we bring this the benefit of Argo to people who doesn't know how to code? Because for the same reason, Argo Workflow has brought a lot of this technology to data scientists who are not entirely very good at coding. Some are very good, but the majority of them are okay at it. So this is our kind of our pyramid of the competence, IT competence within the company. So we have some developers, we have some domain experts, some good ideas. They have a lot of scripts, but they struggle to bring this into the majority of the people that use this technology, scientists, engineers, because they don't really know how to run, for example, single line or Python code. And then we also lack a lot of code to software developed to actually bring this into production. We're thinking, could that Argo Workflow, could that be the bridge to bring some of this not that complex but quite beneficial script or small tools into the majority of the engineers with a no code UI for Argo Workflow. That's how we began. So what we want to achieve is we want to get it fast. You just need to build a Docker container, and you don't have to know about how it actually works within the Kubernetes way or within Argo Workflow. And everything building and running workflow can be done with a GUI. You don't have to worry about a YAML file. You don't have to worry about the Argo Workflow YAML file. We sort that out for you. And these data scientists or people with some coding background can focus on building a Docker container, and with a several line of configuration can build what we call a component, which is basically a steps, a container template in Argo Workflow. And that can be reused for other people. They can take it, grab it, and build them together into Argo workflow. So hopefully, when it works, you don't have to know how to write the Argo workflows manifest. So it's a bit like the Lego bricks analog. The data scientists can focus on, say, building the bricks, which is a single Lego bricks, and then the users can take the different size of Lego bricks and build their house. They don't have to know how that single Lego bricks is built. We don't know. I doubt anyone knows the dimension of single Lego bricks, but we all can grab it, and they all interlock with each other. You can build houses, cars with it. It's the same concept. So the first thing we want to do is we take you step by step with access control first. First of all, the access control within Equinor, it's done by role-based, and we map the Flowify as something called workspace, which is a project or a team within your enterprise would have a sandbox, and they're equivalent to a Kubernetes namespace. And inside this workspace, and admin of that workspace would be able to configure Kubernetes secrets and volume mount for the users that use it in the component and in the workflows. So we don't do any verification. You can use any OIDC client you want. The only thing we do in the Flowify access control is to take the JW token, which currently, because we use Azure, but it's quite straightforward to add other OIDC provider as well. So a quick, just to show you how it actually looks like. I'm going to do the demo. This is what Flowify looks like. The UI, it's a UI and then a server. You can see workspaces. These are actually one-to-one mapped to a Kubernetes namespace, and they have their own Kubernetes secrets that you could use in your Argo workflow. You have your own volume mount that you can use in your Kubernetes workspace. So these are role-based. It's based on your role from your JW token. And if you go to, go inside one of the workspace, you can see the existing workflow available to you. And if you go to this is the admin page, which is where you can configure some of our advanced things that you would use, for example, secrets, volume mount, depends on your blob driver. So this is something then as a workspace admin, you can figure out, and you don't have to let the user worry about it. So this is the first step into the Flowify RAM, which is the workspace. It's a sandbox environment. Every sandbox has its own secret and etc. And it's all sandbox within the workflow is also restricted into the workspaces as well. So let's go into the more useful stuff. We built something called bricks and graph, which is an abstraction of the Argo's container set template. A brick, it's basically an instruction to run a single container. And the graph, it's down. It's basically multiple Argo container set template that interlock together and become a workflow. It's basically a workflow. I'll come back to this later, why we differentiate bricks and graph, but this is mainly for the super user to understand, or for people who build component to be worried about. The normal user who build workflow doesn't need to worry about this. So the fundamental part, the lowermost level would be what we call a component, which can be a brick, or a graph. So you can create a component clicking this button. I'm going to show you an example of bricks. We can view this example. It's basically an instruction to run this container with entry point, with a bunch of arrays, and then on the left-hand plane, it's what specify for Flowify the input and then the output, and then this would be mapped into the argument. So if you have an input for Flowify, it's called array, and then it would map to this array input and would be passed into the entry point of your Docker command. So this is just your box standard a way to construct the entry point command to run a Docker container. So this is what we call a component, but you can also have multiple components that multiple bricks that interlock together into a graph. It's basically a workflow, but the benefit of it is you're able to abstract a lot of this to the user, because at the end of the day, the user will only see the input and then the output of the component. They don't worry, they don't need to know about whether it's a single container or it's a multiple container. You can put graph, so you can go to graph, and then you can add multiple this existing bricks. These are all bricks, so you can all add these bricks together, and then you can link them together using this drag and drop interface. So you have this input, Flowify input map into the bricks. So then what the user see, they only see array and index. They don't see what's inside. So but that's essentially is a dark. So the user-facing part, it's a bit slightly different. We call it component versus workflow. As I said, it's about abstractions. So you can have a single bricks, which is a single instruction to run a container, or it's a chain of container as a component. But what's important is you can abstract all this away, and the local user will only see the input and an output, where they can go to the workflow and chain them together. So you can actually, if the component is a graph, that means you can have graph within a graph, which it's become a nested dark. Or it can be bricks connected to bricks, which is just a simple dark, and you just run as a workflow. So that's the level of abstraction we're trying to provide to the user. So what you can do in here, this is, say, my persona is a local user. I don't know anything about Docker. I don't know anything about YAML. What I can do is I can come in and create a new workflow. So I already have a new workflow. You can click this one, create a new workflow. So I have this one already done. So you can create a graph. A component is always a graph. And then you can add things that is called, say, different things. You can have upload data. You can have a config parsers. What you can do, the user can then go to your input, add input to your workflow, and then workflow can link together. It has some type checking, but we haven't really come to a conclusion what is the best, because you don't want to restrict too much for the local user. So we haven't found a sweet spot yet, but there are some minimal amount of type checking about what the type of that input would be. And then you can chain them together. I can't do that because the output is a parameters, and this one is asking for artifact parameters, then I can put them together. And then the user can also use the mount, and these work set up for them by the workspace admin. So you can take whatever that's available in there. We don't have that in this workspace yet, but I believe we don't have a secret. Then you can get the secret, and this will pass into environmental secret as you do, let's say, in Argo Workflow. Then user can just run it. So not a single line of code. They need, this one can be a break, this one can be a graph, but it doesn't matter. The implementation of the component itself, it's completely hidden, so they don't get scared. So this is what we have built at the moment in terms of the user interface. The architecture is in here, the deployment. The OIDC flow, we just use OAuth proxy. We don't have a choice as long as you send your JW token in the authorization header, in the bearer token, then it's fine. And then Flowify just get the token, verifies it, get whatever claim that we use to identify the user and also the roles. As I said, we only have Azure because we only have Azure in Equinor, but we are very happy to help if any other OIDC provider. But with here, we need some help from the community to at least get some example token for us to work with, because we don't have other cloud provider for use yet. And then we have this, what you see with this component workflow, all this document has an intermediate layer. We have something called Flowify manifest, just an intermediate layer before we generate the Argo workflow manifest. And we store this in the MongoDB. And this Flowify manifest, when user construct a workflow, and then Flowify server, when it's submitted, Flowify server would generate the appropriate the Argo workflow manifest, and then it just use the Argo workflow API to submit it, and then the server would check the progress, and then Argo workflow it would then be responsible for execution of the workflow, because we're not going to reinvent the wheel of all the hard work that Argo workflows had done with several people within Equinor. What we want to do, we want to leverage the power of Argo workflow and build a wrapper layer on top of it to make it easier to use. So we have, if you go to our documentation site, we have a local Docker Compose image that you can spin up and test around. We have example database in there as well. Just follow the instructions. If you want to deploy it in your institution, have a go. Take contact with us. We are very happy to help you to set it up. We have dedicated team to support this. So at the moment, this project come out of Equinor research, and we exited research, and is now hand over to our IT operations team. So the aim is to spend the bulk of next year to bring it into production. And that's here we want to show it to the community, and we want to show it to you and have some opinion how this works, and also hopefully create a community around it as well. And then the team on the right, we have four and a half people working on it. But so don't be hesitate to contact us. We have a discussion board on GitHub. Just post anything if you need help. We're very happy to help. If you see there's missing features, or if you can't get the local test environment running, just give us a shout and have a look in the documentation. We do need some help to see what's best for Equinor within our institution may not be the best for others. So we want to find the middle ground, and also we find and then So in short, just contact us, give us a shout, and give it a go. And I think that's it for me. If you have any questions.
Yeah, let's open it up for questions. Anybody?
This looks great. So is it fair to kind of summarize this as like a UI for constructing workflows, right? Instead of kind of like, of course, writing YAML for meaningful workloads is complicated. So this kind of provides a way of kind of, drag and drop components, and you can connect one to the other, and eventually behind the scenes, Flowify will create the Argo workflow, right?
Exactly.
Go ahead.
Carry on. Sorry.
No, go ahead. You have to say something.
Yeah. That's true. This is what you do. Create this component and workflow. We create an intermediate document called the Flowify manifest, which is a simplified version, and then we base on that to construct the Argo workflow. If there's a need, we can also give you a capability to retrieve that generated Argo workflow YAML file, the Argo manifest. That could be useful. We thought about that. And also we implement, except this nested that, we also have some more advanced feature we are testing, like conditional statements and parallelization. So I think the parallelization works quite well.
Oh, you're
So-
doing some additional parallelization outside of what Workflows itself does? Or making use of that feature, you mean, but in a user-friendly way, or?
Yeah, so we do have a way to, if you can see my screen, I'm not sure, but let me do it. So if you can see this screen, let me see, that works. So we have something called a functional component, which is map, which is parallelization, which allow you to say, I want to run this workflow multiple times. Then you can map this, run this multiple times. That means if you have what we call a parameter array, if you create input, which is an input is a parameter array, which is basically a list. You can add a bunch of array number and then connect it to this map component. Then it will run this component for every single of these items. Then you can go into, these are a little bit advanced feature that we just finished and we are testing out right now.
Pretty nice. I mean, I could see even people that know how to use the YAML, it would be nice for them to just be able to connect these things and without having to write the YAML itself.
So you mentioned about like this data scientists, for example, being one of the users of the system.
Yep.
So they are going to have to write some of their own code as well, right? So if I'm a data scientist and I want to do some, say, model training or whatever, query S3 and then do some sort of like data cleanup and whatnot. So if I have to write that 10-line code, how do I go from like those 10 lines to this UI and be able to kind of construct the workflow?
Yeah. So the thing you only say, we can go to one of these simple components. Say this is a very simple component. It just it's an HTTP get. It just get a random number. So what you have to do is just
I see.
create something in the Docker image. So you just need to create a Docker image that run this Node.js script or Python script, for example.
Sure.
So that is the only thing that because we're not sure other institution, but for Equinor, then for us, a Docker is the standard way for deliver any application. So as long as you can, as long as a data scientist know how to package a Python script into a Docker, then that's just straightforward.
I see. So if people want, oh, sorry, go ahead.
And there's a UI for adding these components. You can do this all from the Flowify UI.
Exactly. So this is the UI.
Awesome.
You just where's the image, the entry point. This is the one this index.js, and then this would be the argument that got passed into. Say, for example, this is the fixed component constant, and I have an argument that is taking what you see here, the Flowify input into here. So URL equal that whatever that string go into here would then append to URL equal XYZ, for example. And then it will append into the chain of arguments and then go into your Docker entry point, basically. It's a way to concatenate your entry point arguments.
That's so cool.
Yeah, so the only thing you need to do in the code is just make sure you have a Docker image.
I guess, and as time goes by, these images would get built for various different use cases, so they could get reused across teams, across projects, across different workflows also. That way,
exactly.
kind of build. Yeah. Awesome.
So this is something we have. It's called marketplace. At the moment, every single component you make, it's in this marketplace, which can be used for all the workspace. In the future, we also consider some team may have some secret. They may want to have some component that is within their workspace, but we haven't implemented that yet. But this is everything you see in the marketplace can be used.
Very cool.
Is it possible to, if you already have Argo Workflows YAML, to add that to one of these components in Flowify?
we haven't thought about the reverse transpilation yet. So at the moment, it's just one way. So we just go from the Flowify to the only thing we reverse transpile. It's probably the job manifest, because then we need to transpile it back so people can see it in the UI. But then the Argo manifest is not at the moment. Yeah.
Cool. So the primary, I guess the first use case right now it's built for is UI to Argo Workflows YAML. Okay.
Yeah.
Yeah. Any other questions we have? Awesome. Thanks so much, Adam. Yeah, and thanks to
No
your
worries.
team for open sourcing all this. This is amazing. We messaged the docs out here, so check that out. Once again, Adam, anywhere else you want to point people to check out Flowify?
I would post it on the Google Docs. Yeah, I will probably share the PowerPoint afterwards. Post a link. Yeah.
Yeah, if you could post the link in the Google Doc, that'd be awesome.
Yeah. Cheers. Thanks for inviting us.
Yeah, thank you, Adam. Great presentation. All right, and let me hand it over to David now. So exploring messaging systems with Argo events. And David, I think you had a blog post.
Yeah, maybe you could just open it up and put in the
Yeah.
background. Otherwise,
Sure,
I'm just
yeah, that.
talking. Yeah. Thank you.
There we go. Can you see my screen?
Yes.
Awesome. Hand it over to you then. Tell me where to go if you need me to go anywhere.
Right there is good. Thanks, Galen. Hi, everyone. My name is David Farr. I work here at Intuit. So I'm not on the Argo team at Intuit. I actually am on the data platform team with Intuit, but I get to work in close conjunction with the Argo team. And primarily, we tend to work on Argo events the most. So we make contributions to the Argo events project. I recently wrote a blog post called Exploring Messaging Systems with Argo Events. So please check that out if you haven't had the opportunity to already. I'm going to post a link to this in the Zoom chat, and it's also in the community docs, Google Docs. And then there's also a link to a short survey there. We're interested to learn a little bit more about how, folks on the call might be using Argo Events, using sensors in particular, and like the choice of the event bus technology has on the way that sensors work, and particularly on the way that they scale. So the reason that we're doing this is, on my team at Intuit, we use Argo events to coordinate Argo workflows. When other workflows complete, we run other workflows, and this is done through Argo events. And one of the issues that we have with Argo events is that it necessitates a large number of pods in our Kubernetes cluster because Argo events creates one deployment per sensor. And because of the way that clusters are managed at Intuit, we have a pool of IP addresses, and every pod consumes one IP address from that pool. And if we have too many Argo events deployments, we have contention on this resource. And because of this at Intuit, the total number of pods in any given cluster, it must adhere to a strict resource quota. That's just the reality of the way things are. So we know this is a problem. And then we also know that sensors or dependencies and triggers, which are part of a sensor definition in Argo events, they can be aggregated together into a single sensor. Both fields are indeed arrays. And this would relieve our issue since we'd be putting all of these workloads into just a single Kubernetes deployment and therefore less pods. You might be aware that unfortunately, the sensor deployment in Argo events as it is implemented today doesn't actually horizontally scale. So if you've ever specified a replica greater than 1 in the settings of a sensor, you can do this, but any additional sensor pods on top of that initial 1 will actually just be in standby mode to enable high availability. And there's actually a leader election that occurs. And if the leader pod is to fail at any given point in time, a different pod is elected as a leader. But at any given point in time, only a single pod is processing events in an Argo event sensor. So this actually presents kind of a unique opportunity for us because we could kill two birds with one stone. So, we could resolve the issue that we're seeing on the ground at Intuit, where we've just got too many pods in these clusters, while also enabling horizontal scalability on these sensors. And then we can increase the performance and the throughput of these sensor applications for all users of Argo events. And this is something that, I think would be beneficial outside of just Intuit. It's something that, the project might benefit from on a wider level. And in addition to that, we also suspect that we can improve the consistency of the application while we're at it. We do see some dropped events here and there, hoping that we might be able to shore these up while we're diving deeper into how a sensor works. So it's probably too much to go over in the community meeting. So I would ask you to take a look at the blog post if you're curious to learning about this in much more detail. Hopefully not too much detail. The blog post is a little bit verbose. But long story short, in the blog post, I put forth an argument that Jetstream, which if you're familiar with Argo events, that's the current Argo events event bus. It's the messaging system used to handle these transitory events. Jetstream might not be the best technology choice for achieving horizontal scalability. So in the blog post, I explored two alternatives, Kafka and Pulsar. And I also explore how these technologies can be leveraged to enable that horizontal scalability that we're looking for. So please check it out if you're interested. I do want to say we don't, my team, we don't have a vested interest in one or the other. If we're going to go Pulsar, if we're going to go Kafka, if we're going to go some third party that we're not even thinking about, or if we're going to maintain Jetstream because, it's the one that's already there. So it's already been implemented. We're mostly just looking at this from the perspective of we want to achieve that horizontal scalability in Argo events. And we suspect that one of Kafka or Pulsar might be a good choice to make. But if you have a different opinion on the matter, we would love to hear from you. We would love to hear if horizontal scalability is something that you're interested. Is this a problem that you're seeing in your Argo events deployments? So I've put together a quick survey. There's a link to it in the Zoom channel and then or in the Zoom chat, and then there's also a link to it in the Google Docs. It should only take 3 minutes to fill out. Please go ahead and do so if you're so inclined. We would love to hear from you. And yeah, with that, I think we can just open it up to questions.
Did you want to put a link in CNCF Slack as well, or
yeah,
just make sure you get visibility for all those Argo events users?
Yes, I will add that after this meeting. Thanks, Julie.
And then one thing I just wanted to mention is you were thinking of, while Jetstream is sort of managed by Argo events, I guess you were looking at Kafka and Pulsar as something that would sort of be external to Argo events as an optional a bus, right?
Yeah, that's a good call out. I don't think we'd want, or users of Argo events would want a built-in deployment of something as heavy as Kafka to your cluster. It's probably something that a lot of companies have dedicated already in-house. So this would probably be an optional add-on to Argo events.
Mm-hmm.
One quick question. I'm not as intimately familiar with Argo events as maybe some of you are, but why does, two questions. One is, why does every sensor need its own deployment? And then secondly, even if it were, in the common case, you would you would see like 5, 6, 8 types of sensors at most, right? So that would mean 6 or 8 IP addresses, but that's not a lot. You mentioned about like running out of IP addresses because there is one deployment per sensor, but like, are there cases where you'll run like, I don't know, tens of thousands of sensors in a
Yes, we're
cluster?
running tens of thousands of sensors out into it. Yes.
Yeah, I mean, you can
Wow.
group triggers into sensors. So you can have, multiple triggers in a single sensor, which are all doing different things, but
Oh, so you're saying if for
Yeah.
kind of sort of each event is one sensor,
No,
or each
no,
event source is a sensor?
neither. Event source is independent. Those are the core concepts of Argo events. A sensor is the object that acts on events and triggers actions based on those events.
Okay. So for example, like I know there is a timer event or so whatever, whichever term but if I want something to run every say 10 minutes, so at the end of every 10 minutes, there's going to be one sensor that runs.
Yes, and
Okay.
you can aggregate these together into a single
Got
sensor. So you could have one
Oh,
sensor
okay. Fair.
with 10,000 different triggers, but if you were to do that, all of those workloads need to run on one pod, and that's the way that it's currently implemented.
Then it makes sense that you could have tens of thousands you could run on IP addresses. I thought like timer, Kafka event, S3 uploading something in an S3 bucket, webhook. These are sensors, and I was like, how many different types of these can there be? Like, what you're saying makes
finite. That's a good point. There's about 15 different event sources that Argo event supports out of the box.
Okay, yeah.
And Kaylin, if you switch back to the blog post really quick, at the very beginning, there's a 10,000 foot architecture diagram of Argo events. And way oversimplified. But I'm talking specifically about the sensors that exist on the right side of the diagram. Event sources produce events, and they're on the left side.
Fair. That makes sense.
And the survey is very short, so everybody should click on it and fill it out. I guess my question for you, David, was to, just kind of dig in a little bit more on if you're comfortable sharing what's one of the use cases that you saw from like the machine learning platform perspective and Intuit that really drove why you'd need this new architecture. It would be helpful to hear for others.
Oh yes,
facing those problems.
So at Intuit, and specifically on my team, this is what my team works on. It's not part of the Argo project. It's it's an in-house application. It's called BPP, Batch Processing Platform. And in BPP, any developer at Intuit can create a batch processor. You do this in what we call the paved road. It's like a UI where you go and you author a batch processor. So any developer at Intuit can create a batch processor. They of course have to write the code, the logic. At the end of the day, you get a Docker container out, the usual stuff. And then these batch processors can optionally be wired together into a pipeline. Underneath the hood, this all uses Argo Workflows. However, the way that one workflow might invoke another workflow is through Argo events. And that's how it's implemented on our team. And what you end up with in the total potential space here is if you imagine a graph where every node is one of these BPP processors and every edge between the nodes is a sensor or something that manifests in Argo events. So in the worst case scenario, it actually grows exponentially, because in the worst case scenario, you might have every single BPP processor invoking every other processor when it finishes. In the real world, obviously, it doesn't work like that, but that's the worst possible case. And that's the reason why we see, because it grows exponentially, so many of these sensors where you might not otherwise expect to see that.
Very cool. Thanks for sharing that. And I think some of your colleagues did a talk at ArgoCon, right, related to this. So I think we have the link below in the community document if you scroll back down to October or so. And they kind of went through that whole architecture, I think.
you have a Rakesh and Bala's talk, maybe? Is that what you're referring to?
Yeah, that was it.
Okay.
Okay. Yeah, in the workflows track and events track at ArgoCon. Okay. Yeah, check that out. I think we have the link down below in the community doc. Yeah, any other questions for David? Awesome. Well, yeah, thanks everybody for joining. Yeah, if you enjoyed the presentations today, give us a clap emoji in Zoom here. We'll see you in January. And if anyone else has talks or demos like this they want to share, blog posts, you know, like David did today, it's perfect for the community meeting. So just DM me on Slack at Kaylin. You'll find me in there. And happy holidays, everybody. Thanks for joining.
Thank you.
Thank you so
Thanks,
much.
everyone.
Bye-bye.
Happy holidays.